Thank you so much for having us. Huge thank you to the FinTech Sandbox, to Gene, to Chad, to Sarah, to Dinesh, to everybody else that's helped us out. In addition to our data partners, FactSet and Capital IQ, we really appreciate it. My name is Ben Israelite, and I run business development at Nutonian, and I am here to show you the future of analytics. The data scientist was named by Harvard Business Review as the sexiest job of the 21st century. And I think that everybody here can understand why that's a fair assessment. The impact that data-driven decision-making can have on a business has already been proven. But the reality is, the scale has not nearly achieved what companies thought it would. And the reason for that is simple. There are not nearly enough people who have this skill set to be able to make the impact that is necessary to really leverage the data that especially companies here have. And that's because the current process of model building is completely manual. There are some tools that can aid in that process, but nothing that really helps that process. And we're seeing that in organizations today. The number of business problems that they're trying to solve is growing exponentially. But the reality is, the insights and the information that they're getting out of that data is still a trickle. We believe that machines are the future of analytics. We believe that, as with so many other industries that have seen machines come into play, be it farming or automotive, that analytics will benefit from the leverage of machines to be able to solve mission-critical business problems at scale. What I'm saying is, your data needs a hero, and I'm here to introduce you to it. This is Eureka. Born out of the Artificial Intelligence Lab at Cornell University, founded by an MIT 35 most innovative minds in the world, also named a Forbes top 7 data scientists in the world. Eureka goes through billions and billions of combinations in minutes to tell you the most accurate, most interpretable model at any given level of complexity. I'm going to hand it over to Jay Schuren, our field CTO, who will show you exactly how it works.
Excellent. Thank you. So before I jump in, I just want to thank the FinTech Sandbox. When we first joined the group, we had one financial customer. Since then, we've been invited to speak at the Wall Street Trading Association twice, and it's by far our biggest vertical, and things are just taking off. So I really appreciate the opportunity you guys have provided. So we're going to dig into today is this concept of evolutionary search and learning from data. Specifically, what signals are useful to answer the question you're asking, doing that in seconds so you can iterate. The first question is often not a good one. The fifth, getting there in 5 minutes, is worthwhile. So let's walk that through in the case of, say you're a real estate investment trust and you want to understand what's governing the difference between short and long-term interest rates. And we have a demo to walk that through. So to start with any of these problems, you need to get some data in. You can either upload or connect with one of the financial data providers. In this case, for this demo, we'll start to pull that information from FactSet just to get some sample information to work with. The problem you'll see is looking at 15 years of data at the monthly level with roughly 100 or so different economic indicators pulled in. So what we're going to do is leverage this concept of evolutionary search in Eureka to go through these hundreds of inputs and in minutes pull out what are the most critical predictors for this problem. And here's where we fundamentally differ from deep learning and the current direction of analytics. The problem is models by themselves are not a strategy. So when you have something that says sales are 7, how do you use that information? You can't see the drivers, you can't see the interactions. The value and where we differ is we're searching for the simplest, most predictive models, leveraging billions of candidate solutions and continually evolving those so we can find places like that blue dot where that is the simplest, most predictive model by penalizing complexity. So we say complexity is governed by how many inputs or the type of math operator. So we can find something that's human interpretable that you can stitch into your strategy. And that's incredibly useful because there's so much risk with overfitting and with this idea of false correlation. By finding the simplest, most predictive model, your team can read it. And in this case, fixed investment growth, changes in the labor force, trade balance. These are the critical drivers over the past 15 years for this gap in interest rates. And if you have a question or you say, why is it fixed investment growth? you can immediately come in, click on it, and say, what else is trending or correlated with it? And then your domain expert can immediately see fixed investment growth and GDP are about the same thing. What means more for your business? That expertise is what we're trying to provide, and then the means to immediately block those. And here's a case where we can see GDP is highly correlated. So the value here is you have a question, you have candidate data, we'll scour it, find those inputs, and then let you iterate, apply the domain expertise, and then answer those questions in minutes instead of days, months, what have you. I know we've gone a little bit over. The video's just wrapping up. Apparently my thank you took too much time.
Perfect. And so what you're actually seeing here is not only do we actually show you what the model is, you can easily export it, you can copy it out, you can put it into whatever environment you want. We have a RESTful Python API where you can actually connect directly to the feed or the database or wherever it is that you want to pull from. We can also export all of that information either to a report that's interactive or to your database system or whatever environment you want it to be in, be it a visualization tool or other. For some reason, it's sort of redoing it. But so we'll get through this and then we'll be done in a second. And really where this starts to be very impactful is we can now build models at scale by doing them all in tandem through a Python environment. And where we start to see that be really important is, we're doing sales forecasting for a car manufacturer where they want to know what are sales going to be at every given location, a regional model and a global model. And right now, that is impossible for them. They've been trying to solve it with 6 PhDs for a year. They built one global model. The reality is how cars sell in Boston is not nearly the same as how they sell in Florida. Plus now we can stitch in census data, NOAA weather data, and we can tell you on a weekly level exactly what will happen over time. I know I'm going to wrap up here. So what we're really looking for is anybody in the audience that wants to know not just what, but why. Anybody who wants to be able to leverage the data that they have available to them to really drive insights and push analytics to the future and do it at scale. Thank you so much.